Alright, 4.4, polynomial and rational inequalities. Okay, we have already learned one method of solving this problem. I'm going to show you guys another one. If you graph this, the graph looks something like this. I'm going to sketch it out.
Alright, we'll see you later. See ya.
Okay. Let's see here. 1, 2, 3 has an intercept here. It goes something like this. This is 1, and this is 3. Okay, so I'll just label these points so there's no confusion. This is 3, 0, or sorry, negative 3, 0. This is 0, 3, and this is 1, 0. Okay, so they're asking, where is this greater than 0? This function is greater than 0 from negative 3 all the way to 1, and then at 1 it hits 0, and then after 1 it goes on to infinity. There we go. Much faster than the last way we learned. I'll let you guys try the try. Okay, solve the inequality x to the 4th power minus x algebraically and graph the solution set. Okay, so if I subtract x from both sides, I get x to the 4th minus x is greater than 0. I'm going to factor this. X cubed minus 1. Okay, now I'm hoping you guys remember your difference of cubes from Algebra 2. Hopefully. X cubed minus 1 simplifies to, factors to x minus 1 times x squared plus x plus 1. Okay? So, x equals 0, x equals 1, and this one doesn't ever equal 1, so we're just going to deal with these. If you were to set this equal to 0 and try to factor it, you'll see that it doesn't factor. If you plug it into the quadratic formula, you'll see it has no real solutions. So we're just going to deal with these. Alright? Here's 0. Here's 1. Alright. This is a method that you guys should all be familiar with, so I'm just going to tell you what the answer is. Let's see here. This is positive, this is negative, this is positive. Okay? So, it is greater than 0 from negative infinity to 0 and from 1 to infinity. If you had trouble with this one, let me know at lunch tomorrow or during class, and I'll help you out with it. Okay. Alright, let's take a look at example 3. So the first example we solved by graphing. The second example we solved algebraically. This one they want us to solve it by graphing again. So I'm just going to draw a quick sketch of what the graph looks like. Actually, let me pause the video and draw it. Okay, so the graph looks something like this. I labeled one point here and I labeled the asymptotes. This graph is greater than or equal to 0 from negative 2 all the way to 1. Okay? And it includes 1 because it equals 0 at 1. And then from, this is 2, from 2 to infinity. Alright, you guys, I'll let you guys try this one. Alright, last example. Okay, this time we're going to solve it algebraically. Okay, so what I'm going to do first, I've got 4x plus 5 over x plus 2. I'm going to subtract the 3 over to the other side, so now it's greater than or equal to 0. This is the same as 3 over 1. I want to get a common denominator so I can combine it all in one fraction, so I'm going to multiply top and bottom by x plus 2. So now I've got 4x plus 5 minus 3 times x plus 2 all over x plus 2. I'll distribute the negative 3. 4x plus 5 minus 3x minus 6 over x plus 2. 4x minus 3x is x. 5 minus 6 is negative 1. So this is what we're trying to find. Okay. The 0 of this function is obviously x equals 1. But it's also undefined for x equals negative 2. So I'm going to use both of those. Here's negative 2, and here's 1. Okay, and once again, I'm confident you guys can all do this part, so I'll just tell you this is positive, negative, and positive. So it's greater than or equal to 0 from negative infinity to negative 2, bracket, because it's underlined, and bracket from 1 to infinity. Alright, I'll let you guys do the other one.